Good morning, students. Let us start our class today doing question from exercise 1.3 based on the topic composition of functions. I have selected question number 9. Read question number 9, in which we are given consider the function f from the positive real numbers to this interval, semi-closed interval starting from -5 to plus infinity, given by f of x is equal to 9x square plus 6x minus 5. Show that f is invertible with f inverse of takes y onto the image under the root of y plus 6 bracket minus 1 upon 3. So this question we are given the domain which is positive real numbers, the codomain which is starting from -5 ending at plus infinity, and the function is a quadratic function defined by the expression 9x square plus 6x minus 5. If I could show that this function is 1, 1 and onto, so that is the necessary condition for a function f to be invertible. So here I start. To show f is 1, 1 and onto. Okay, that means f is a bijective. So for 1, 1, what is the condition? Let f of x1 equals to f of x2. How is the function defined? F of x is defined like this. So f of x1 would be 9x1 square plus 6x1 minus 5 equals to 9x2 square plus 6x2 minus 5. Simplify this expression. Minus 5 cancel out. 9x1 square minus 9x2 square plus 6x1 minus 6x2 equals to 0, which implies 9 times of x1 square minus x2 square plus 6 times of x1 minus x2 equals to 0. So it says x1 minus x2 is a common factor. Take that out. You are left with 9 times of x1 plus x2 plus 6 equals to 0. The product of two terms is 0. Either the first is 0 or second is 0, which implies x1 minus x2, this bracket is 0, or 9 times of x1 plus x2 plus 6 is 0. First bracket implies x1 is equals to x2, or I can have this also, that x1 plus x2 equals to minus 6 upon 9, which is a negative quantity. Both x1 and x2 belongs to R plus, so their sum cannot be negative. So this condition is ruled out, not possible. Therefore x1 equals to x2 is the only condition. So we started with f of x1 equals to f of x2, and it reveals that x1 equals to x2. Therefore I can say f is 1, 1. Okay, for unique point in the domain, it has a unique image. Secondly, now I am defining showing that f is onto also. To show f is onto, that means the codomain is the range of the function. Select any point. Let y belongs to minus 5 by 5. Y belongs to close interval minus 5 to infinity is any element. Let, if possible, y can be written as 9x square plus 6x minus 5. I am seeking out the possibility for which y is the image of some point of the domain of the function. Simplify that for what values of x this is possible. So simplifying, I will have 9x square plus 6x minus 5 minus y equals to 0. This is a quadratic in x. So get the value of x. X will be equals to, apply the formula minus b plus minus under the root d upon 2a. Putting the values, minus 6 plus minus under the root b square minus 4ac. So what is b square? That is 6 square minus 4, a is 9 and c is minus y minus 5 upon 2 into 9. So simplify further. This is minus 6 plus minus under the root 36 plus 36 bracket is y plus 5 divided by 18. What can you take common? Minus 6. From here 6 is out, so you are left with 1 plus y plus 5 upon 18. Simplifying further, cancelling out 6, so that shall be equals to minus 1 plus under the root y plus 6 upon 3. And there is a plus minus, right? So x can be minus 1 plus under the root y plus 6 upon 3, or x can be minus 1 minus under the root y plus 6 upon 3. But this value is not possible because x belongs to R plus. Hence only possibility is this. Okay children, let us resume the question. Here I have taken a point, any element in the set closed interval minus 5 to infinity, right? Y should be greater than or equals to minus 5. Y plus 6 will be greater than or equals to minus 5 plus 6, that is 1. So under the root y plus 6 is greater than or equals to 1. Minus 1, when added to it, minus 1 plus under the root y plus 6 divided by 3 should be greater than or equals to 0. Hence x is greater than or equals to 0. Hence x belongs to R plus, which I am assuming to be this interval 0 to infinity. Then only it is possible. So x is now written as minus 1 plus under the root y plus 6 upon 3 belongs to R plus, which is the interval 0 to infinity. Hence x belongs to domain of the function. Therefore, for any y which belongs to the codomain here, there is an x which is of this type belongs to the domain of the function. Therefore, the function is invertible. Function is invertible means f inverse does exist. And how is that f inverse defined now? F inverse is going to be a function from the set minus 5 to infinity to the set R plus, and it takes y onto the function minus 1 plus under the root y plus 6 upon 3, such that f inverse is identity on this set minus 5 to infinity, or which also implies that f inverse of is going to be the identity on the set R plus. Hence I have proved that f inverse exists, and which is also 1, 1 and 1, 2, and composition of f with f inverse is an identity. Same way f inverse composition with f is also an identity function. This is one of the way of proving that such a function is 1, 1 and onto. There is one more method I am going to take up. There I will show that second method. I'll show that define g from the function from the set -5 to infinity to r plus, and show that g is also 1, 1 and onto. Then g is invertible. Then I will show that FOG is identity on this function -5 to infinity, or I can show GOF is identity on the function R plus. Therefore, G and F are inverse of each other. G is F inverse. Okay.